a little bit more of guided practice before I am gone next week. So let's work through just these 3 problems. Is there 3? Yeah, there's 3 on here, and make sure you guys know what you are doing. Is this off? This is off. So the state speech and debate tournament is here next weekend? Mm-hmm. That's crazy.
Yes.
Feels like a lot of work.
Yeah, it is. You shouldn't be hosting it again already because we hosted it when I was a freshman.
Well, do you make money off of it?
Yeah. It's supposed to shuffle around the state, so each district gets a chance to host it in the fundraiser. But
So why is it here?
because Coach Custer wanted it here.
Rule on top.
No, incorrect statement because my tournament's at Edwin, so incorrect statement.
Aw,
Keene Elementary.
that's so cute. You get to go to Edgewood and pretend like you're an Edgewood Admiral again.
Yeah, and the final round is in the band room.
Ooh. I've got some.
The final band round is in the orchestra room, and so it gets so hot. Yeah, with no yeah, it's great.
There were 2 when I did band in 6th grade.
Those were the good days.
What'd you play? I was so bad. I never played the flute. I was just like, because you can't really hear it when the whole band is playing, so I just like sit there and pretend I was playing. I never learned anything.
Did you get an A?
Oh
Yeah. Good. Cool. Anybody have good plans for the weekend?
No.
No.
I'm going to be prepping
For what?
for states.
Oh, got it.
I'll be prepping again.
Okay, cool. Here we go. Hydrogen cyanide gas, HCN, is a powerful respiratory inhibitor. In other words, it suffocates you. That was a nice way to say it. Is highly toxic. It's a very weak acid, Ka small, when dissolved in water. If a 50 milliliter sample of 0.100 molar hydrogen cyanide gas is titrated with 0.100 molar NaOH, calculate the pH of the solution at these 2 spots. Spot number 1 at the halfway point, spot number 2 at the equivalence point. So, what would be, we haven't done any math in a while, your guess on how to start letter A? I don't need an equation for letter A, actually. So, what do we know?
It's a weak acid. Well, we know it's a weak acid in the strong base.
Okay,
That's about.
so that's a buffer. At letter A, what do we know about the halfway point? Think about yesterday.
It's.
On those last 2,
It's.
what is true at the halfway point?
It's.
No, that's the equivalence point.
Oh, whoops, yeah. Half of the base.
Now you're on the right track.
Half of the base, or half of the base that will be added in the equivalent when it's been
Not necessarily.
added. Half of something.
It's equal amounts of the salt and the.
Yes. At the halfway point, there is equal amounts of acid and base present. Or you could say acid and salt, however you want to say that. But those should be equal. Or we could say where the volume added is half, I know, mind-blowing, of what it will be at equivalence.
That's what I was trying to say. It just isn't.
Yeah, I kind of knew where you were going with that. What else do we know about the halfway point on a titration curve?
What word is after word?
Volume or where volume added is half of what it will be at equivalence. What do we know about the halfway point? Why is it special? From the notes. I know, it's been a while since we've taken notes. There was something special about the halfway point. 2 things were equal at the halfway point. Brady, have you watched the notes?
I don't think I got to that part.
What did you say?
I got to that part.
Okay.
Half what?
Halfway. half of what it will be at equivalence. What is special about the halfway point? What's special about the halfway point? Two things are equal at the halfway point. What two things are equal?
Concentration of, is it like concentration?
We already said that. We already said that the acid and base are going to be equal.
Those substances in the conjugate acid base.
True. But what else about the halfway point is special?
pH equals pKa.
Thank you. At the halfway point,
Where is that in the next line?
pH
Is that the, like second to last page?
equals pKa.
Am I blind?
pH equals pKa.
No, flip the page right there.
So what did they give me in the beginning of this? They gave me a Ka.
Duh.
So I need to
Okay. Take a
take a P. Get out your calculator.
Oh, and then you just.
Do you know what take a P means, Brady? Oh boy. Yes.
I was here.
Half of what it will be at equivalence.
Oh, and then once we get that, we
She said she was there that day and she doesn't even know what it is.
I know, but you should know what take a P means at this point.
Log it.
Negative log. So all I have to do, if pH equals pKa, all I have to do is figure out what's the pKa. Well, pKa is the negative log of 6.2 times 10 to the negative 10th. What do you get when you put that in your calc? Negative log of 6.2 times 10 to the negative 10th. 9.21. So, once again, you did not need an equation. You did not need ice. You just had to think about where are we at in this titration. So on these questions, I've been saying, do it the smart way. Okay, do it the smart way.
when doing it, I still get you the same answer.
Sure.
It was just a lot more work.
It would be more work, but you could still get the same answer. Letter B. Letter B says at the equivalence point. So, what do we know at the equivalence point?
Neutral P,
Why?
because there
Concentration of H plus
it's zero, it's gone.
should equal
The concentration of OH minus.
the concentration of OH minus, right? Because at our equivalence point on all of those, right, we just had ions floating. Well, for our strong acid, strong base, right? Concentration of H equals H plus. So the first thing I would figure out would be how much HCN was originally present. How much HCN was originally present. So in order to figure that out, we can do that. Now I would write an equation. So here's my R. So my equation is HCN, but really, it depends how you want to write this. Because on this one, I want to figure out, so I have HCN with NaOH, right? So what I'm going to do is I'm just going to start with the ion, Cn minus. We'll start with the ion, add it to H2O, and that's going to be in equilibrium with my HCN plus my OH minus. What is the thing I actually care about here?
Why did you start with the
I started with the ion because I'm trying to figure out how much HCN was originally present. This is what I'm trying to figure out. So in order to figure that out, I'm figuring out with my ion and water, that's what made my HCN. So how much of this is originally present? Now, for my Cn minus, my initial, what do I know?
You know the molarity.
I have 50 milliliters, right? And I have 0.100 molar, agreed?
Yeah.
And that was titrated with 0.100 molar. So, what is my moles gonna be here?
We have to figure out the middle.
What?
We have to figure out the middle.
What if I work in millimoles? How many millimoles do I have?
I can't. Bruh.
What's a mole?
A millimole is like 1/1000th of a mole.
Is it 10?
You're like 10?
I have 5, right? Because if I have 50 milliliters,
50 milliliters.
right?
Yeah.
If I multiply that, I have
Oh, we have 8 hours.
5 millimoles, right?
That makes me sad.
Divided by, what's my volume going to be?
We have to figure out how much on.
What is my total volume going to be? So I have 50 milliliters of
We
this.
have to figure out how much NaOH is on.
At the equivalence point, if I put 50 of this in, yes,
Oh, okay, we added.
over 50 milliliters plus 50 milliliters. Because if I take millimoles and I divide it by milliliters, what do I get? Moles. Water's not part of this. Do I have any of my HCN?
I don't know what's going on.
What?
I don't know what's going on. Wait, could you zoom in?
Can I zoom in? Yeah, I can zoom in. What if I just kept zooming out? So we're saying because this is at the equivalence point. I started with 50. In order to get to the equivalence point, and I'm going to have to add 50 more.
Of what?
I have 50 milliliters of HCN is titrated. So I'm saying that I added 50 milliliters. It doesn't
Oh,
matter.
you added 50 milliliters of the NaOH.
Yeah,
Oh, okay.
in order to get that to the equivalence point. So,
Wait, are you adding that just because it's the same amount?
correct. Because I know at the equivalence point, in order to get these equal, yes, you got it. So my HCN is going to be nothing. So I have nothing to start with here, and I have no OH to start with. Yes.
If there was a different molarity of the NaOH, would we then have to figure out how much is added in a different way?
Yes, but because these are the same molarity, that's why I can assume 50 milliliters of this is going to take 50 milliliters of this. That's why I can do 50 of this, because they're the same molarity.
And you started with ions of the CN because you're trying to figure out how much HCN was originally?
Exactly. I'm trying to figure out how much HCN did I start with.
That makes me, yeah.
That's why I'm starting out with the ions here. So my change is going to be minus what? Minus X. Minus X. Water's not part of it. Plus X, plus X. At equilibrium, 5 divided by 100, what is that? That's 0.05, right? Yes?
Yeah.
0.05 minus X, not part of it, X and X. Okay, now what? So if I write out my K expression, right? What K am I writing out here? KA or KB? Do I have any concentration of H plus?
Oh, H minus 7, KB.
I'm going to write a KB, right? Because this is a base,
Oh,
right? So KB equals,
Well, what is the point if we actually write K and K instead of KB and then everything else is X?
on my test, I think you would not. I would not take a point off for that. On the AP test, I don't know if that would be showing understanding of what you're actually doing. So it depends on the rubric.
That's valid.
Depends on the rubric how they set it up. KB equals X squared over what?
0.05 minus X. Oh, but wait, can't we just go to 0.05?
0.05, right? X is small. K is small, right?
Literally doing nothing.
So because K is small, it's just over 0.05. Shoot.
that only works for on the bottom.
Correct. Well, what is KB? I can't solve this. How am I going to get KB?
Just put something for X.
But I don't know what X is. So in order to solve for X, I have to know what KB is, which means there must be a way to figure out KB.
Wait, how'd you,
Is it with KA?
wait, hold on. Wait, how'd you get just 0.05
It
at the
says
bottom?
Because it's just KA is small, so this X goes to 0.
Oh, okay.
It says the same ones for POH or PP.
Wait, but Ka is small, but that's Kb though. So how do we know that?
Do you remember when I said that KA times KB equals KW?
No.
That's the K of water, which is a constant that we always know. Sorry, Brady. You really got to watch these notes. Which means I could rearrange that and say that KB is equal to KW over KA.
Wait, why is it over KA? Oh, that's.
I just divided. I just divided. That's a multiply.
That would be
Because
a
Ka
lot.
would have to be big.
Ka.
Wait, no, but if Ka is small, then Kb
What?
would be.
Does not matter for this.
Wait, then what is this about?
I'm solving for KB.
Yeah.
I have to get KB to solve for X.
Oh, wait.
I already have Ka and Kw is a constant.
Yeah.
So
Give us the constant for water.
the constant, you gotta know it's 1 times 10 to the negative 14th. You just gotta know that.
Oh, right, yeah.
It's 1 times 10 to the negative 14th. It's on the yellow cards.
Oh, yeah.
It's on the yellow cards. So that means that Kb is equal to 1 times 10 to the negative 14th over, they gave me the Ka way up here, right? Over 6.2 times 10 to the negative 10th. I can now solve for Kb.
Are we allowed to assume that it's at 298 Kelvin?
Yeah.
What, that would be so.
On the AP test, it'll say at standard
That would be
conditions.
so mean if they made us.
Yeah,
When you're able to do that.
you wouldn't be able to do it. So Kb, when you divide those, is what?
It is 1.61 times 10 to the negative.
1.6 times 10 to the negative fifth. So now, this Kb can be substituted in over here to solve for x.
So now we know it's small because we found it.
Well, we already knew that Ka is small.
Well, yeah,
Right.
we know Ka is small, but how do we know that Kb is small?
Well, we don't really care if Kb is small.
Oh.
We needed the Ka small to get rid of this x.
Wait, what-
We don't really care if this is small. We just know that it's small. That doesn't mean anything at this point to us. It's just small.
Okay.
So I'm going to substitute this in over here. So 1.6 times 10 to the negative fifth equals x squared over 0.05. Solve for x. And x, what do you get?
.9 times 10 to the negative 4.
That's what I had. I had 8.9 times 10 to the negative fourth, which is equal to my concentration of what?
HCl?
That's equal to my concentration of OH minus,
Right? They're both X.
which is both x. But I'm asked to calculate the what?
pH.
The pH.
Oh.
So I am going to take, what am I going to do with this number? This is I could take the negative log of this to get the what?
POH.
POH.
14 minus 9.
You got it. So the negative log of 8.9 times 10 to the negative fourth, that will give you your POH, which is what?
Brady, on a scale of 1 to 10, how lost are you right now?
Yep.
POH of what?
I got 3.5.
3.05, which is equal to POH. Therefore, pH equals what? Come on, mental math.
10.95.
10.95.
That's a pretty basic one.
10.95. POH?
POH.
POH. So to get pH, I have to do 14 minus the POH to get the pH. The 14 minus.
Pretty basic.
So, it is pretty basic. So once again, this is not hard. None of these things are hard. It's just trying to figure out how am I starting, right? What am I starting with? And after that, you get to here, and then you're like, oh crap, I can't do this. That must mean that you can figure out X or KB, which we can figure out KB.
And the problem wouldn't be unsolved.
Exactly. Flip it to the back. One more.
Uh-oh.
So, a chemist has synthesized a monoprotic weak acid, which is important, and wants to determine its Ka value. To do so, the chemist dissolves 2 millimoles of the solid in 100 milliliters of water and titrates the resultant solution with 0.500 molar NaOH. After 20 milliliters of NaOH has been added, the pH is 6. What is the Ka value of this acid?
That's a great question.
What would be the first thing you would do?
Ice table.
We don't have an equation. You can't make an equation. You don't know what
Well, I don't even have an equation, so I can't write an ice table. What could you do first? What could I solve for here? What can we do with the numbers they gave us?
Oh, PKA.
POH, right? Because we have
More simple than that. I have a molarity of NaOH
moles.
and I have a volume of NaOH.
Moles of NaOH.
The first thing I would do would be figure out the moles of NaOH.
So real.
So I would take my 20.00 milliliters of NaOH, and I'm going to multiply that by the molarity, which is 0.0500 molar. This is going to give me millimoles, which is fine. You want to do it in moles, you can do it in moles. Either way, this is going to work out the same way. How many millimoles of NaOH do you get from that?
It's gonna be a small number.
20 times 0.05. Huh? It's 1. So I have 1 millimole of NaOH. So that means the chemist dissolved how many millimoles of acid?
2 moles.
The chemist dissolved 2 millimoles. Agreed? And how much NaOH have I put in so far?
1 millimole. So there's been 1 millimole of acid that hasn't reacted yet.
True, but what else is this telling us?
Halfway point.
I'm at the halfway point,
Yay.
right?
Not the equivalence point.
Because I've put in, I'm not at the equivalence point,
Halfway point.
I'm at the halfway point. Because I've put in 1 millimole of NaOH. The original solution, right? The original solution had 2 millimoles of my HA, of my acid. So this equals the halfway point. And I know at the halfway point, what?
The concentrations of the acid and the base.
From the front page, we said what's special about the halfway point?
pKa equals
pH equals pKa. So my pH is what?
6.
6. So 6 equals pKa. How do I undo a pH?
10 to the negative 1.
10 to the negative. So that means that 10 to the negative 6 is equal to what? What does that give you? Yes. 1 times 10 to the negative 6 is equal to my Ka.
100% because you need acid.
Yes. So, once again, I wanted to show you somewhere like you would think, I gotta ice this. You can't even ice this. I don't even have an equation, right? Figure out, what do you know? Because I just wanted to give you some of these problem-solving techniques. The answer is 1 times 10 to the negative 6. Because 10 to the negative 6 is 1 times 10 to the negative 6. So, make sure you're
so
thinking.
Much space on this page.
I know,
feel like I need to
but I just wanted to work through a couple like that and show you, okay, I put in 1 millimole, I have 2 millimoles, I'm at the halfway point. Or maybe you get to a point where you can just Henderson Hasselbalch it. Right, Brady?
Oh, yeah.
Yeah.
Brady, how long to?